Okay, today let's talk about just sort of the second part of 2.6 that's going to show up when you start doing the homework. So this sort of forces us to recall what we learned in like 1.4, which was absolute value equations. Now we have to write absolute value inequalities from a sentence into like a mathematical statement. Okay, so let's start with the date today. And then I'm going to just call this 2.6b. And we'll call it writing absolute value inequalities. Okay, here's the key. Remember that to write an absolute value equation, so remember an equation will have an equal sign. Now we're talking about inequalities, so in this case we won't have equal signs anymore. We'll have our absolute value statement, our absolute value expression, and then we'll have an inequality sign. So recall that an absolute value equation is x minus the mean of a set of numbers is equal to the distance of that mean from either end. So remember, if we had like our number line, and we have, say, our mean here, and then we have sort of our max and our min, right? And each of these little parts was a distance. And then to set up our equation, we would take x minus the mean, and it's equal to this distance. Now the only difference with absolute value inequalities is that instead of having an equal sign here, we're going to have obviously an inequality sign. So we'll have greater than or less than, or greater than or equal to, or less than or equal to. So let's do a couple of examples. These are not in the book, so this is one of these classic big idea situations where they don't show you how to do it as an example, and then it shows up in the homework. So I'm just going to call these like 1, 2, 3, even though they're not necessarily examples 1, 2, and 3 from the book. So for example, let's say a number is less than 5 units from 0. A number is less than 5 units from 0. So we're going to use this principle up here, this little equation for absolute value, to help us write the inequality for absolute value. Okay, a couple things to notice. Inequality sign, we'll use less than. We'll have a number, which is going to be our variable, okay, x or n or whatever it tells you, it wants you to use. In this case, it just says a number so that you can pick the variable. Okay, 5 units, this is going to be our distance, right? If it's 5 units from 0, this is our distance. And from 0, that means that 0 must be our mean, right? If it's 5 units on either side, then 0 is our mean. Okay, so then we can just put this together as an absolute value inequality. X minus the mean, in this case 0, is less than the distance, 5. Okay, and then my last step in this case is going to be to simplify, because x minus 0 is always going to be the same as x. So the absolute value of x is less than 5. The second thing it's going to ask you to do is solve. So you'll go through your steps. Can I, first of all, solve this absolute value inequality? Yes. Okay, if the absolute value is greater than 5, that makes sense. I can continue to solve that, meaning I will split it. x is less than 5, and x is greater than negative 5. Remember, we flip our sign and take the opposite. And then if we graphed this, it would look like this, right? And this is our mean somewhere in here. I'm going to simplify this because I told you to do this, so I want to make sure I'm following my own directions. Our solution is this, right? Remember, because it's an and inequality, we started off with a less than. It's going to be an and inequality, meaning I need to simplify my answer into one statement. Okay, and then my graph is going to look like this. Open circle at both ends, and the absolute value would fall somewhere between negative 5 and 5. Let's do one more. Okay, number 2. Let's say half a number is at most 7 units from 12. Half a number is at most 7 units from 12. Okay, so let's break this down. First, we're going to have half a number. Okay, so we can write that as 1/2 x, right, or 0.5x, or x over 2. They all mean the same thing. So half a number is at most. Okay, and remember, an equality sign for is at most is less than or equal to. 7 units is our distance, and 12 is our mean, right? Because we're saying that it's either 7 units on either side of 12. So this is our distance, and this is our mean. So let's write this as an inequality. 1/2 x minus the distance, 7, is less than or equal to 12. So that's our absolute value inequality. Then it's going to ask you to solve. Okay, so then we're going to double check. Can we solve this? Yes. Less than or equal to 12. So we can split this 1/2 x minus 7 less than or equal to 12. 12, and 1/2 x minus 7 greater than or equal to negative 12. And then we'll solve. Plus 7, 1/2 x less than or equal to 19. How do I get rid of a fractional coefficient? You multiply by the reciprocal. So we are going to multiply both sides by 2. Don't divide by 1/2. You are more likely to make mistakes. X is less than or equal to 19 times 2 is 38. And plus 7, 1/2 x greater than or equal to negative 5. And to get rid of this fractional coefficient, I will multiply by the reciprocal. So x is greater than or equal to negative 10. All right, then to graph this as one big inequality, I'll put my lowest value, negative 10, my x in the middle, and my 38 at the end. And my graph would look like this. I would be going all the way from negative 10. I'm going to go past my mean, which we said was 12, and all the way up to 38. So my graph would look like this: closed circle at 10, closed circle at 38, and then a line connecting the two. All right, the last one I want to show you, just be careful of this happening. Okay, number 3. Let's do twice a number is no less than 5 units from negative 2. Twice a number is no less than 5 units from negative 2. So what do we have here? First, twice a number, we would write that 2x, right? Twice a number is 2 times that number. Is no less than. No less than means greater than or equal to. 5 units is our distance. And -2 is our mean in this case. Okay, using our same formula, we'll do 2x minus -2. Okay, x minus the mean is no less than, so greater than or equal to 5. And I must simplify right here where we have minus a minus. I need to make that like a plus sign. Don't leave this because it's not simplest form. So make it absolute value of 2x plus 2 is greater than or equal to 5. Okay? And then from here you can split and solve and graph. But just be very careful that when your mean is a negative, you're going to have a positive when you simplify within the absolute value equation. Okay, that's it.